Hey everybody, it's your boy Gerald and welcome back to the channel. I wanted to talk about something interesting today, Open Telemetry and observability as a whole. I've been doing some learning and experimenting with Open Telemetry and I figured I'd share it with you all. So really when we're talking about observability, it's made up of a few different concepts. We have logging, we have tracing, and we have metrics overall. Logging being more so thought of as like logging what's happening inside your code, maybe within a function call. And then if you're talking about metrics, you're talking about something like tracking at runtime when my code is running, the CPU usage, or how many requests I'm getting over a specific amount of time, things like that. And then traces specifically would be referring to more so a collection of requests over time to combine into one story that a user would be telling as they use your application. And we're going to get more into that in a second. Now, logging, tracing, and metrics all combined together make up what we call telemetry. And we use this telemetry data to actually then fuel how we're observing our application. And ideally, do some monitoring and alerting when we see certain things that show that our overall software system is out of whack. Now, if you're like a lot of people, you may be asking, why isn't logging enough? Why do we need tracing? Why do we need all of these metrics? That's because logging in and of itself is much more condensed usually to the code that's executing itself, maybe within the context of a function call. And there's very little context of what's going on externally, like where something was called from, right? And when you get into microservices and breaking up things out of a monolithic architecture to then being called over the network, now we have this distributed situation where we need a way to provide context across these distributed services. The first step in adding context to our logs is combining our logs into something called a span. A span is just something that contains your logs and also provides additional context. Like, for example, it may include where this particular code was called from. It may include other metadata and attributes that we can add to it that give us context as to what was calling this, when it was calling it, and what happened when it was called. The concepts of adding context to our logs and creating these spans leads us into tracing. It actually enables tracing because spans individually can be looked at as building blocks that create traces. Honestly, I would say this became a much larger problem as microservices gained popularity. In the days of the monolithic application where all of our code was included in one code base, making different function calls and being able to walk through and debug every call was a lot easier than it is today, when we have all of these services now broken out of the code base into their own separate code bases and then called as an API or web service individually. Let me illustrate what I'm talking about. So if we had a monolithic application, let's say you wanted to go buy something online, and our app allows you to do that. You may, in a monolithic application, have multiple function calls that allow you to do that. Potentially, hey, let me select item. So I may have a select item function. Then I might have an add to cart function. I probably have a login function as well so that I can track what users are trying to buy what. And then I would have something like a checkout function that would take in credit card data and actually facilitate the purchase. Then if something went wrong in that situation, I could just set breakpoints and walk through each of those function calls and see what the heck is going on. When it comes to microservices, you can still go through those individual code bases and set breakpoints and debug, of course, but it's a lot harder to understand how those services are interacting as a group to facilitate something like this user going through and making a purchase, because every button that person's clicking and every action that they're initiating may be its own separate code base. Now, what Open Telemetry sets out to do is to unify how we accomplish observability, regardless of what language you're writing your app in, etc. Observability is really how we see what's happening in our system from the outside, and it allows us to account for why something is happening, which is especially helpful when something happens you didn't expect. And as especially in large companies, the more you the more code you add and the more services you have, the higher the likelihood that something is going to go wrong. Open Telemetry seeks to accomplish observability through a few common concepts that they break down into what's called signals. These signals are composed of some things we've talked about already: traces, logs, metrics, and then a fourth one that's especially interesting, which is called baggage. Now, baggage is how Open Telemetry establishes that shared context between these distributed code bases, these distributed web services, APIs, etc., so that as data is flowing that composes one single user operation, like shopping and purchasing something out of a shopping cart, you can share context of what's happening along the way and then compose it into one thing that allows you to now see what's happening from the outside in your system. Let's use a similar example to our monolithic application to illustrate why you might want to use baggage in this kind of observability framework we're talking about right now. So instead of this being one monolithic application, we're going to decompose each one of those function calls into 3 individual web services that would each have their own URL essentially. Let's say we have a login, then let's say we have a add to cart and then a checkout. URL, each one having their own URL and each being their own APIs essentially. So what we can do with baggage is solve a problem like, hey, I really want to understand how it looks when my user goes to check out. I want to see how every single service correlates together, and I want to be able to search that based on customer ID. The problem that we have in these separation of services is that the customer ID is only given to us in the login service. So you would utilize baggage as an example to put that customer ID into that baggage that then is passed on to the other service. Now we have the customer ID at every single web service tracked under one specific umbrella composed of multiple spans, a span per service. And those spans aggregated and put together now compose our trace. Open Telemetry enables observability in a few different ways by supplying tools that allow you to collect, transform, and then export your telemetry data, also providing per language SDKs and enablement around automatic implementation. If you enjoyed the video, I'd love if you left a comment. If you'd like to hear more about Open Telemetry or content like this, just open source in general, would love to know more about that. And I hope everyone has a great day.